Open neutral protection functions by interrupting the electrical circuit when the neutral wire becomes disconnected. This disconnection can arise from faults like a broken wire or a loose connection. When the neutral wire is open, the voltage on the circuit can escalate to dangerous levels, presenting a shock hazard. Open neutral protection devices, also referred to as ground fault circuit interrupters with open neutral protection, or GFCI/ON, monitor the flow of current on both the hot and neutral wires. If the current on the neutral wire becomes too low or non-existent, indicating an open neutral, the GFCI/ON device trips and breaks the circuit within milliseconds. The requirement for GFCI/ON protection for storable pools over 15 volts is predicated on the increased risk of shock in a water environment. Storable pools are typically smaller and more likely to be used in areas where children are present. The open neutral protection is an added layer of safety to prevent shock from any electrical faults that may occur. Pools over 42 inches in height are not subject to the same requirement because they are considered to be more permanent structures. They are also typically used by adults who are less likely to be in contact with the water while operating electrical equipment. Additionally, larger pools often have bonding and grounding systems that provide additional protection against electrical hazards. However, it's important to note that even for pools over 42 inches, it is still good practice to use GFCI/ON protection for any electrical fixtures near the water. This provides an extra level of safety and helps prevent electrical accidents. Let's delve deeper into the specifics of open neutral protection. Imagine an electrical circuit as a loop, with current flowing from the source, through the load, and back to the source via the neutral wire. The neutral wire is typically grounded at the service entrance, providing a return path for the current and maintaining a stable voltage. However, if the neutral wire becomes disconnected, this return path is disrupted. When this happens, the voltage in the circuit can become unbalanced. Devices connected to the circuit may experience overvoltage, which can damage equipment and create a shock hazard. In a normal operating circuit, the hot wire carries the voltage, say 120 volts, and the neutral wire is at or near 0 volts. The difference in potential drives the current through the load. If the neutral is open, the return path is lost, and the voltage on the hot wire can fluctuate wildly relative to ground. This is where open neutral protection comes in. A GFCI/ON device is designed to detect this imbalance. It continuously monitors the current flowing through the hot and neutral wires. Under normal conditions, the current flowing through both wires should be equal. However, if the neutral wire is open, the current flowing through the hot wire will not return through the neutral wire. This creates a difference in current between the two wires. The GFCI/ON device detects this difference and trips the circuit, cutting off the power supply. This happens very quickly, typically within milliseconds, to prevent electrical shock. The sensitivity of a GFCI/ON device is usually set to a very low level, such as 5 mA. This means that it can detect even a small difference in current between the hot and neutral wires. This high sensitivity is essential for providing effective protection against electrical shock. Now let's consider the logic behind the exemption for pools over 42 inches. The National Electrical Code, or NEC, sets the standards for electrical safety in the United States. Section 680 of the NEC specifically addresses swimming pools, fountains, and similar installations. The NEC recognizes that swimming pools are inherently hazardous environments due to the presence of water, which is a good conductor of electricity. Therefore, the NEC mandates various safety measures to minimize the risk of electrical shock around swimming pools. One of these measures is the use of GFCI protection for electrical circuits serving pool equipment. However, the NEC also recognizes that different types of pools present different levels of risk. Storable pools, which are typically smaller and temporary, are considered to be more hazardous than larger, permanent pools. This is because storable pools are often used in areas where children are present, and they may not have the same level of bonding and grounding as larger pools. Bonding refers to the practice of connecting all metal parts of the pool structure and equipment together with a conductive wire. This creates an equipotential plane, which means that all metal parts are at the same voltage. If a fault occurs, the voltage will be distributed evenly across all metal parts, reducing the risk of shock. Grounding refers to the practice of connecting the pool's bonding system to the earth. This provides a path for fault current to flow back to the source, tripping the circuit breaker and cutting off the power supply. Larger pools typically have more extensive bonding and grounding systems than storable pools. This provides additional protection against electrical hazards. Additionally, larger pools are often used by adults who are less likely to be in contact with the water while operating electrical equipment. For these reasons, the NEC does not require GFCI/ON protection for pools over 42 inches in height except for specific applications such as underwater lighting. However, it is still good practice to use GFCI protection for all electrical circuits serving pool equipment, regardless of the size of the pool. This provides an extra level of safety and helps prevent electrical accidents. Now let's talk about the practical implications of all this. Firstly, it is imperative to understand the differences between GFCI and GFCI/ON devices. A standard GFCI protects against ground faults, which occur when current leaks from a hot wire to ground. A GFCI/ON device provides additional protection against open neutrals. Secondly, when installing electrical equipment near a pool, always follow the manufacturer's instructions and local electrical codes. This includes using the correct type of wiring, conduit, and fittings. Thirdly, regularly inspect all electrical equipment around the pool for signs of damage or wear. This includes checking for cracked insulation, loose connections, and corrosion. Fourthly, never use electrical appliances near the pool while you are wet or in the water. This greatly increases the risk of electrical shock. Fifthly, if you are unsure about any aspect of electrical safety around the pool, consult with a qualified electrician. They can help you ensure that your pool is safe and compliant with all applicable codes. To further clarify, let's discuss bonding and grounding in more detail. Bonding is the process of connecting all metallic parts of a pool together electrically. This includes the pool structure, metal ladders, handrails, diving boards, and any other metallic equipment within a certain distance of the pool. The purpose of bonding is to create an equipotential plane, which means that all bonded metal parts are at the same electrical potential. This helps to prevent voltage differences between different metal parts, which can cause electrical shock. The bonding conductor is typically a solid copper wire that is connected to each metal part with a bonding clamp. The size of the bonding conductor is specified in the NEC. Grounding is the process of connecting the pool's bonding system to the earth. This provides a path for fault current to flow back to the source, tripping the circuit breaker and cutting off the power supply. The grounding electrode is typically a ground rod or ground plate that is buried in the earth. The grounding conductor is connected to the grounding electrode into the pool's bonding system. The size of the grounding conductor and the type of grounding electrode are specified in the NEC. Proper bonding and grounding are essential for electrical safety around swimming pools. They help to prevent electrical shock and protect people from injury. Now let's move on to some specific examples of how open neutral protection works in practice. Imagine a scenario where a storable pool is set up in a backyard. An extension cord is used to power a pool pump. The extension cord has a damaged neutral wire, resulting in an open neutral condition. If a person touches the pool water while the pump is running, they could receive an electrical shock. However, if the pool pump is protected by a GFCI/ON device, the device will detect the open neutral condition and trip the circuit, cutting off the power supply and preventing the shock. Another scenario involves a pool light that is powered by a 120-volt circuit. The neutral wire to the light becomes disconnected due to corrosion. This causes the voltage on the light fixture to fluctuate wildly, creating a shock hazard. If the light fixture is protected by a GFCI/ON device, the device will detect the open neutral condition and trip the circuit, preventing the shock. In both of these scenarios, the GFCI/ON device provides an added layer of safety by detecting and interrupting open neutral conditions. This helps to prevent electrical shock and protect people from injury. To summarize, open neutral protection is an important safety feature that helps to prevent electrical shock. It works by monitoring the current flowing through the hot and neutral wires and tripping the circuit if the neutral wire is open. GFCI/on devices are required for storable pools over 15 volts due to the increased risk of shock in a water environment. While pools over 42 inches are not subject to the same requirement, it is still good practice to use GFCI protection for all electrical circuits serving pool equipment. Proper bonding and grounding are also essential for electrical safety around swimming pools. They help to prevent electrical shock and protect people from injury. Always follow the manufacturer's instructions and local electrical codes when installing and using electrical equipment near a pool. If you are unsure about any aspect of electrical safety, consult with a qualified electrician. They can help you ensure that your pool is safe and compliant with all applicable codes. In addition to the above, it's also crucial to understand the role of ground fault circuit interrupters in overall electrical safety. A GFCI, as previously mentioned, is a device that protects people from electrical shock by detecting ground faults. A ground fault occurs when current leaks from a hot wire to ground, often to a person's body. GFCIs are designed to trip very quickly, typically within milliseconds, to prevent serious injury or death. GFCIs are required in many locations around the home, including bathrooms, kitchens, and outdoor areas. They are also commonly used in swimming pools, hot tubs, and spas. When a ground fault occurs, the GFCI detects the imbalance in current between the hot and neutral wires. If the difference in current exceeds a certain threshold, typically 5 mA, the GFCI trips the circuit, cutting off the power supply. This happens very quickly before the person can receive a dangerous electrical shock. GFCIs are an essential safety device that can save lives. They are relatively inexpensive and easy to install. If you do not have GFCIs in your home, you should consider having them installed by a qualified electrician. It's important to regularly test GFCIs to ensure that they are working properly. This can be done by pressing the test button on the GFCI. If the GFCI trips, it is working properly. If it does not trip, it should be replaced. Open neutral protection, as incorporated in GFCI/on devices, adds another layer of safety, specifically addressing situations where the neutral connection is lost. This is particularly important in environments where electrical equipment is subject to vibration, corrosion, or physical damage, which can lead to loose or broken neutral wires. In these situations, a standard GFCI may not provide adequate protection, as it primarily detects ground faults, not open neutrals. The GFCI/on device, however, is designed to detect both ground faults and open neutrals, providing comprehensive protection against electrical shock. In conclusion, electrical safety around swimming pools is a complex topic that requires careful attention to detail. By understanding the principles of open neutral protection, GFCI protection, bonding, and grounding, you can help to ensure that your pool is safe and compliant with all applicable codes. Always consult with a qualified electrician if you have any questions or concerns about electrical safety. Remember that electricity and water can be a dangerous combination, and it is important to take all necessary precautions to prevent electrical shock. Prioritize safety in all aspects of pool maintenance and operation to ensure a safe and enjoyable swimming experience for everyone. One final note regarding the evolution of electrical codes and safety standards. The NEC is updated every 3 years to reflect new technologies, safety concerns, and best practices. It is important to stay informed about the latest changes to the NEC and to ensure that your electrical installations are compliant with the current code. Local jurisdictions may also have their own electrical codes that are more stringent than the NEC. It is important to check with your local building department to determine the specific requirements for your area. The electrical industry is constantly evolving, and new safety technologies are being developed all the time. By staying informed and embracing these advancements, we can continue to improve electrical safety and protect people from harm. And don't forget the importance of education. Educate yourself, your family, and your friends about electrical safety. The more people who are aware of the risks and how to prevent them, the safer everyone will be. Share this information with others and encourage them to take steps to protect themselves and their loved ones from electrical hazards. Together, we can create a safer environment for everyone. Always remember, when in doubt, consult with a qualified electrician. They have the knowledge and experience to help you ensure that your electrical installations are safe and compliant with all applicable codes. Electrical work can be dangerous, and it is always best to leave it to the professionals.